Learning Objective 4.2 is about identifying and computing measures of position. So we've previously talked about the standard deviation as the most widely used measure of dispersion, but there are other ways to describe the spread of data, and that includes the location of values that divide a set of observations into equal parts. So these measures include quartiles, deciles, and percentiles. So a quartile breaks something into 4 equal parts, deciles break it into 10 equal parts, and percentiles break it into 100 equal parts. And this equation here is how you would calculate the location of a percentile. So let's take a look at this percentile computation. LP refers to the location of a desired percentile, N is the number of observations, and P is the percent. So if we wanted to find the 33rd percentile, we would use L33, and if we wanted to find the median, which is the middle, then that would be the 50th percentile, L50. So now let's take a moment and look at an example. So here's an example. Listed below are the commissions earned last month by a sample of 15 brokers at Salomon Smith Barney's Oakland, California office. They're asking us to locate the median, the first quartile, and the third quartile for the commissions earned. So I want to clarify that the median is at the 50th percentile, the first quartile, percent, is at the 25th, and the third is at the 75th percentile. So step one is to organize the data from lowest to highest, and we've done that here. And step two, we are going to compute the first and the third quartiles using our location of percentile equation. So let's work our way through these. All right, we know that our N value, number of observations, is 15. For L25, it's going to be 15 plus 1 times the percent is 25 over 100. Okay, when we do that, we get an answer of 4. Now let's do this for L of 75. Again, we have 15 as our number of observations. The only change here is our P is 75. When we do this, we get 12. Now this is very important. This 4 and 12, these are not our answers. Okay, the 4 is the position in the data. So we need to go back up here and we need to find the fourth piece of data. So we have 1, 2, 3, 4. So that is our fourth piece of data. So the first quartile, right, the first quartile is at $1,721. Then we are going to find the third quartile, which is at the 12th spot. So we are going to count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here is our 12th position, 2,205, and that is our third quartile. Next, we are going to find the median. Remember, the median is the middle. That's at the 50%. If you want to, you can write out L50 and calculate it that way. But since we have 15 pieces of data, and that's an odd number, we will have a median in our data. And we can go through and we can cross off until we find our middle number. Okay. So our second quartile, or the median, is $2,038. So in our previous example, the location formula yielded a whole number. What would happen if we had an even number of observations and we wanted to locate the first quartile? So in this scenario, the first quartile would be at the 25th percentile. We get 1.75. And so we need to do some calculations to find the 1.75 position. So locate the first value in the ordered array and then move 0.75 of the distance between the first and the second values and report that as the first quartile. So just like the median, the quartile does not need to be one of the actual values or observations in the data set. So if you look here, the first and second values are 43 and 61, right? That's between 1 and 2. So if you move 0.75 of the distance between these numbers, the 25th percentile is 56.5. And we got that by doing 43, which is the 1, plus 0.75 times 61 minus 43, so the difference of those two.